All right, PreCalc, I'm hoping that you finished filling out your chart. I have my values on the chart as well. I actually grabbed this from an old file so that you can actually read them, okay? So don't be afraid to just stop the video right now, pause it, and check your chart to my chart and see if our values line up, if they look like they're the same. And I ask you at the bottom to identify patterns found within the chart, okay? I have mine color-coded by quadrants, and then we'll also look at some values as that. I'm hoping what you found with your chart is that you didn't have to go re-rationalize anything because you found that all the values that we put into our first quadrant were just used over and over and over, okay? Hopefully you noticed there were some signs that changed, okay? When I look in, mine are blue right now in the second quadrant, I notice all my signs are positive, but my cosines are negative, and my tangents are negative, okay? And when I go to the third quadrant, it looks like sines and cosines are negative, but my tangents are positive, okay? And the same, when I go into the fourth quadrant, I notice that my sines are negative, but now my cosines are positive, okay? That's huge as we use this chart and as we try to figure out values. So I'm just gonna make a little pattern down here that I found. And I do want to tell you that I can't get my stylus to work correctly, so I am using my finger. So let's hope that everything stays legible. Okay, so I need to be careful how I say this. I keep saying the sign as in positive and negative, but there's also the sign as in sine, cosine, tangent. So hopefully I don't confuse you with that. But right now I'm talking about the sign as far as positive or negative in each quadrant. Okay, because there is definitely a pattern and there definitely holds true. So in the first quadrant, when I look at the positive or negative value of sines, it looks like everything is positive. Cosines, it looks like everything is positive. Tangents, it looks like everything is positive, okay? When I go into the second quadrant, my sine, which are my y values, it's still positive. But my cosine, which goes with my x values, because I went left, is now negative. And my tangent, which if you think about it, is the sine over the cosine. If I have a positive and a negative, I should be negative. So it looks like it holds true to what's in my chart. When I go to the third quadrant, my sine, which are my y values, those are negative, so my sines are negative. My cosines, which go with my x values, those are negative. And my tangents, which actually go with my sine and cosine combined, so a negative and a negative divided by a negative, that now becomes positive. All right, moving into the fourth quadrant, my sines go with my y values, and those are down or negative, so they are all negative. My cosine goes with my x values, those are all positive. And my tangent is a mixture of sine divided by cosine, and a negative divided by a positive is negative. So if I can remember this, which by the way, I have on your big unit circle, it's in the corner of each quadrant, it just says sine, cosine, tangent. And all of a sudden I just had a blank because I don't, yeah, and right beside sine it says cosecant, cosine, secant, and tangent, cotangent. All I'm looking for you to put on your unit circle there is a positive or negative sign beside each one, okay? So, what are some other things you noticed in this chart? Okay, and I'm going to try to look at the whole chart here as a whole. We talked about you didn't have to refigure out a lot of the rationalized values because we found the same values being used over and over. Okay, let's see if I can kind of highlight some of these. And I do have a highlighter, so I have that advantage, right? I notice on my 30-degree line, my pi over 6, I have 1/2 radical 3 over 2, radical 3 over 3, 2 radical 3 over 3, and radical 3. Those same values, so when I look at these values, I see that same list repeat down here to 150, just with some sign changes. And then I see it right away again on 210 with just some sign changes. And I notice those same values one more time, it skips quite a few there until I get down to 330. But they all have the same sign changes, or the same numbers, just with sign changes. Okay, so yeah, that one looks true. Okay, what else? I definitely see, well, with my 45s, I see the radical 2 over 2s and the 1s. I see it again here with 135, just with some sign changes. I see it again right here with the 225, just with some sign changes. And I see them again down here at the 315, just with some sign changes. Okay, so the same values, just the signs changed. Change colors here one more time again. On my 60 degrees, it looks like I start with radical 3/2, 1/2, and go through there. That same thing looks like it comes up again in 120. Then down here at 240, and right away again at 300. So I keep seeing these same values here. Okay. I almost hate to change my colors, but I want you to really focus on especially one column here. Okay, so I'm going to try to do one other color change. Hopefully it doesn't mess this up. I want you to look down here at the radians. Okay, now that I probably messed them up. On all my yellow rows that I highlighted in yellow, what do you notice about the radians on each one of those? The denominator is 6. Pi over 6. It comes 30. When I look at the degrees, I don't always see this pattern, but I see it in the radians, okay, because we're 30 degrees off the x-axis. At 30 degrees, at 150, I'm 30 degrees off. At 210, I'm 30 degrees off. And at 330, I'm 30 degrees off. But it's really obvious when I look at pi over 6, and then I see 5 pi over 6, and 7 pi over 6, and 11 pi over 6, okay? So it holds true for that. Notice, too, when I look at the green rows, I have a pi over 4, a 3 pi over 4, a 5 pi over 4, 7 pi over 4. They all go with my 45 degrees, which that one's a little more obvious because it's halfway between everything. Then on my blue rows, I have a pi over 3, a 2 pi over 3, a 4 pi over 3, and a 5 pi over 3. Those are all 60 degrees off of my x-axis. So 60, 120, 240, 300. The degrees don't seem to line up because they don't, quote, go every 60, right? Which they kind of still do, but the radians definitely match up. And this is one time when you're going to start noticing where radians are so helpful, because what it allows us to do is really figure out what goes together as far as which ones relate. So if you think about it, what we're kind of saying here is anything with pi over 6, we get the same numbers, but with different signs. Okay, and the same thing goes for like pi over 3s. We get the same numbers, but different signs. The same thing goes for pi over 4s, right? So if you think about it, we definitely have these families. So some of you may admit this chart took a while to fill in. You had to be careful. You had to think about where values were coming from. Maybe you didn't pick up on the patterns right away, so you just literally went through one ordered pair at a time and listed the values. And that's good because it helps you to remember where those values come from, how you can recreate those values if you forget them, okay? So I don't want to undermine this exercise at all because it's very important that you could do this. But now, if you want to, I'll give you a shortcut method, okay? So one thing I want to kind of state as I found these patterns is I keep getting the same numbers, just different signs. Well, if I look at what I put over here on the corner here, I put over here my different signs. So if I can just memorize where my different signs go, and if I can memorize my first quadrant, then I don't have to do this whole chart. Okay, and I should rephrase that. Maybe not even say memorize. If I can just recreate that first quadrant chart and recreate these signs every time, then I don't have to do the full chart. Okay, so if you can, get out a clean piece of paper or, just somewhere fresh where you can practice this chart. Okay, so on my first quadrant chart, this is what I'm going to start with. So important to start with 0 degrees. Okay. Then we're going to go to the next one, which is 30 degrees, then 45, 60, and 90. Okay? That's where my first quadrant's going. And I know, like, earlier I kind of put 90 to start the next quadrant, but we're going to just kind of start it right there. Okay. Before we go on, let's put radians with these because we just talked about how that really ties us into the right family. So 0 is just 0 radians. 30 degrees, those are my pi's over 6s. 45s are pi's over 4, 60s are pi over 3, and 90 is pi over 2. Okay. And it's so important when we do this chart, when we go to do it, we put sine first. Okay, then we put cosine. And finally, we put tangent. If I get too close to the top, it doesn't like to read what I'm writing, okay? And you can continue on if you want with your cosecant, your secant, and such on, but I'm going to tell you I'm not going to even fill that out, okay? So here's the deal. You're taking a quiz, you're taking a test, you want to quickly recreate this chart so that you can double check it, you can use it as a reference point, but you don't want to have to sit there with the whole thing with ordered pairs. Okay, I'm telling you right now, this chart, the way I fill it out, has zero to do with what we just did on that big chart, okay? This is like a shortcut method that you just remember the shortcut method and you go for it, okay? So it really requires zero knowledge about the unit circle or its values right now. So label from 0 to 90 in order. Always start with sine, then cosine, then tangent in this chart. Okay, here we go to start filling out, okay? Just follow along and kind of see where this is going. In the first box under sine, I'm going to put the square root of 0 over 4. In the second box, square root of 1 over 4. In the next box, square root of 2 over 4. In the next box, the square root of 3 over 4. And in the last box, the square root of 4 over 4, okay? I'm hoping you got my pattern there. I just start at 0 over 4 down to 4 over 4, square root of everything. Now I'm going to simplify. Well, anything, 0 divided by anything is 0, so the square root of it is just 0. Square root of 1 on top is 1, square root of 4 on the bottom is 2. Square root of 2 on top, it's not even, so I leave it, square root of 2. Square root of 4 is 2. Square root of 3 over 4, the square root of 3 on top is not even, so I leave it in the square root, and the square root of 4 is 2. Square root of 4 over 4, the square root of 4, well, I should just say 4 over 4 is 1, the square root of 1 is 1. All right, that's how I filled out my first column. Now, if you look at your big chart and you compare it, is the sine of 30 degrees 1 over 2? Yes. Is the sine of 60 degrees radical 3 over 2? Yes. All these values match up to our big chart, but we just use this shortcut method to figure it out. Okay, and I just did air quotes right there, but you couldn't see me. Okay. Not bad, right? We didn't even think about the order of pairs. That's how we filled it out. Okay, if you thought that was nice and easy, wait till we fill out the cosine column. To fill out the cosine column, what we're going to do is take our sine column and flip it upside down. So the cosine gets the 1. The 30 degrees 1 up there gets radical 3 over 2. I get radical 2 over 2 in the middle still. I get 1/2, and I get 0. Go check your chart. Is the cosine of 0 1? The cosine of 30 degrees pi over 2? The cosine of 45 degrees radical 2 over 2? The cosine of 60 degrees 1 over 2? And the cosine of 90 degrees 0? It is. All right? We quickly recreated that. Now to do tangent, it's still important to remember that it is sine over cosine, okay? Remember that. So my first column over my second, so 0 over 1. Well, that equals 0. When I do 1/2 over radical 3 over 2, okay? If you remember any of the rationalizing rules, we flip the second one, the 2's cancel, we get 1 over radical 3. I have to rationalize it. I'm going to end up with radical 3 over 3. I know I didn't show that, but the more you do this, the easier it gets. For my 45 degrees, when I go radical 2 over 2 over radical 2 over 2, it equals 1. For 60, when I go radical 3 over 2 over 1 over 2, the 2's cancel, and I'm just left with radical 3. On my 90, when I do 1 over 0, I can't divide by 0, so I get undefined. Okay? I've got my chart filled out. I didn't refer to my ordered pairs. This is it's just a quick cheater way, okay? But it's accurate if you remember the rules. And then if you want the cosecant, secant, and cotangent, just do a bunch of reciprocal work and fill out the rest of it if you want them. This is the core values right here. Okay, these 15 values. If you can do these 15 values and you think of your sine chart, you're going to be good to go. And you can quickly recreate the values that you're going to need from the unit circle. All right? Practice. It's worth it.